Record here. All right. Hey, everyone. This is Program Live, and my name is Tarun. Um, Program Live is a new show about all things developer tools, all things open source. And today I am delighted to have on our show James Cowling, who is the CTO and co-founder of a developer tool called Convex. Now, if you follow me on X, you probably have heard me talk about Convex. And I mean, if you don't live under a rock, you've heard about Convex yourself and probably have tried it. And I think Convex is probably one of the most exciting new developer tools out there for web developers today. So I'm super happy to have James here. We're going to talk about the Convex founding story. We're going to talk about databases. He's going to teach me a bunch of things, and I'm going to ask a bunch of stupid questions. But anyways, without further ado, James, thank you so much for joining.
Thank you, Torrance. It's really nice to be here. Thank you.
Awesome. Cool. So I thought we'd just kick it off by like talking a little bit more about you and your story prior to Convex, right? I think you've talked about your time at Dropbox being a pretty like fundamental sort of part of, what led to Convex. What I'm really interested in is like, what are the types of problems that you solved at Dropbox that kind of led to the founding of a new company? Right?
Yeah.
That was like a really important part of it. It's like you clearly have seen scale, right? You've dealt with these like really like gnarly storage problems at scale. What about that led you to start this company? And feel free to kind of, introduce yourself and talk about Convex. Yeah.
Absolutely. So yeah, maybe if we'd pick out some kind of keywords that kind of will relate to the story of Convex, right? It's about simplicity and scale, right? And I think these are the and can say constraints as well. I think these are three of the most important things in engineering. And I think scale, we just think of scale in this like web scale, number of servers, number of clients thing. But I'm thinking of scale in terms of when you add new features to your application, when you hire new engineers to your company, how do you start with a prototype, something small, and grow into something really very significant, and do that without emergent complexity really destroying your efforts? Um,
Yeah.
and so if I go back in time, so grew up in Australia, I was a very kind of academic person and a little bit conservative, to be honest. I wasn't like ready for the startup world back then. I was kind of a bit afraid, to be honest. And so um, went and did a PhD at MIT, and I got to work with a woman called Barbara Liskov. And Barbara is incredible. And Barbara is a lot of people would know her from the Liskov substitution principle. Barbara kind of invented the concept of abstraction in computer science. It seems that something wouldn't need to be invented, but it was like the
Wow.
idea that before then it was like global variables and you know and there was like a lack of information hiding, right? And Barbara really came along with this idea of subtyping and information hiding, and the concept that you can have a complex system, a complex function, a complex part of a technology, and you can wrap it up in a simple abstraction, a simple model, and you can use that model and it works just as well as knowing how everything inside works, right? And I think, there was back at the time, I know I'm going a long way back now, there was something called the software crisis. And this was like people like Edgar Dijkstra, like these names that you think is like
Yeah.
thousands of years ago, right? Who were like, software engineering is going to grind to a halt because we just can't manage big systems. It's not possible for human beings to manage this complexity. And over time, we got used to the idea in programming languages and systems of coming up with abstractions, right? And these are these kind of tools we use to simplify, managing complex systems. So right now, when you deploy to Netlify or Vercel, you're not really thinking about what's going on in the CDN, right? Or you're not thinking
Mhm.
about what's going on in the build system. You just push the button and it works, right? And to a large extent, it's good enough. Or when you use an operating system, that's these are abstractions. So
Yeah, it's all the way down the OSI stack, right? Like down to the OSI stack is one of the most interesting examples of abstraction at the networking layer too, right?
absolutely. I mean, it's easy. A lot of engineers want to be hardcore, right? So you want to hate on abstractions. You're like, why would I? But you got to get over yourself. Unless you're writing binary right now and directly instructing, like even if you're using an instruction set on your processor, you're using abstraction. But
Yeah.
right? So there's nothing weak about abstractions. There's a very powerful thing, and designing abstractions, I think, is the hardest thing in computer science. It's what I really got a passion for in grad school. And so I went through my PhD, and I came out, and I was going to be a professor. And last minute, I'm like, you know what? I just want to build some stuff. I want to build some stuff. And so I went to Dropbox in 2012. And in 2012, I think the Dropbox infra team was 7 people, approximately. It might have
Wow.
been 9 people. It was about that many people. And it's a great time. It was absolute chaos. My first day was just like, "Hey, James, go find something to do." It wasn't like, "Hey, here's just go figure something out." And um, so Dropbox was a small company with a huge number of users, and it was, I think it was fair to say, falling apart in some respect. The Dropbox went down every Tuesday morning, and then we'd go and like slow down all this. There's a button, like a command called chill out, and it would tell all the
Yeah.
clients to stop sending updates for a while.
Yeah, I
Um,
feel like every successful company has some version of that. At Wattpad, we had this thing called read-only mode. It was like, yeah, this just like it's sort of a signal of success when you can't handle it.
Absolutely. And by the way, everyone should try to have something like this, some kind of like release valve, right? We can talk about congestion collapse way later if we get to it, right? But avoiding that. So I got thrown into this environment. And to be fair, I was not very experienced. I mean, I had professional coding jobs before, but I wasn't the world's greatest programmer, certainly at the time. And, um, and so had a lot to learn. And then soon after that, um, got thrown into like building Dropbox's storage system. And so that became a huge project. I mean, I guess the budget would have been, close to $1 billion, really, if you think about it, right? So you're talking, this is moving Dropbox's storage off of Amazon S3 onto
Hmm.
Dropbox's own in-house storage. That's a whole story in and of itself. We did it very, very fast with a team of um, less than 6 engineers did most of the work to design and build that system. So we moved ultimately many exabytes off of S3 scaled up. We had over 1 million hard drives in data centers around the United States, and we did it um, extremely efficiently. So we were, I think, the first team to launch this new technology called SMR drives, single magnetic recording at scale. And there was a lot of really cutting edge work done on that team. Just super successful project, high risk, uh, small team, um, short time frame. We didn't lose any data. The system still runs just fine. As far as I know, has never lost any data, right? Um, and then after that, that was with my co-founders. And after that, we went and designed the databases and the sync protocol and all this kind of stuff.
Wow.
And so um, in the process, I was at Dropbox for 8 years, and ended up being like the most senior engineer there over time. And a lot of people kind of look to these projects as like, wow, how did you pull off this project? Like you must have been like this, super smart people who sat down and come up with the most perfect design, and then you just did it, and it came out perfectly, right? And I think there's incredible anti-patterns because that's not what it looked like, right? I think if we got something right, we were really, really good at designing for simplicity and elegance, right? Like that's what we push on so hard. It's like, how can we split off this little, I'd call them stepping stones. I've got a whole like philosophy around this. Like
Hmm.
any large engineering project, you should split into these incremental deliverables called stepping stones that are kind of incrementally valuable, but they narrow the state space of systems design for you. So first you build the system with no replication, then you add the replication, then you do the erasure coding, then you do the all this kind of stuff. So we managed to pull this off by designing ultimately a very, very simple system. Now, it's a massive system and there's a lot of lines of code in it, but it's something I could walk through on the whiteboard the design with someone, and even if you weren't a systems expert, you would understand the design for it. Was called Magic Pocket. Um, and it really gave me an appreciation. And also, by the way, you see systems fail. Like if
Hmm.
you're at Dropbox for 8 years during this time frame, and for a lot of that time, all that time I was on call, and for a lot of that time, I was like this. There was a small group of people that if the on-call situation got bad enough, you got pulled in to try to resolve the problem. And Dropbox had what, a 500 million connected devices at the time, I think. And
Wow.
so it's a pretty big deal when Dropbox is down. And so, those constraints were amazing. I feel so fortunate to be in that environment because I could have gone to Google and like Google. obviously incredible company with great engineering, but didn't have those kind of constraints,
Hmm.
right? Because, at the time, Google was already such a sophisticated company with all the systems in place and almost infinite budget. And Dropbox wasn't. Dropbox was scrappy, but we
Yeah.
had big infrastructure. And so this is a long-winded story, but this really gave me an appreciation for how do small groups of people build great things. And you do that by really focusing on simple composable designs. And you know it. You know when a system's simple or when it's not, because when you start hacking and most of simplicity comes from state management, which we'll get to when we talk about convex.
Yeah.
Everyone knows when you look at a system, and things just fit together. Oh, I can just use that with that, and I can layer this with this. And when it's not simple, you know it too, because everything you change, you add one flag over here, and 17 other functions have to change. Right?
Yeah.
And I could talk for hours about this because it's my favorite topic, but all of that stuff culminated in the design of convex, right? Thinking about what are the challenges of application development today. A lot of it is just a lack of good abstractions, a lack of good primitives, and emergent complexity that's really slowing developers down. And I'll
Yeah.
pause there for a second. Yeah.
I guess the thing I would love to get into is like, what are some of those sort of the core kind of technical decisions that you would look back at and say, you know, after you know, your time at Dropbox, you were like, this thing that we do, we have to make sure that it does it manages this well. And I guess is like the state management piece, one of the most important parts of that. Like what are some of
Yeah.
those like core technical decisions? And I think for folks that are watching this that are not familiar with convex, feel free to kind of uh one of the things I also love to do is talk a little bit more about like maybe relatedly are what are some of the kind of like aha moments
Yeah.
that people have with the convex system when they first start using it? I'm sure those two things are sort of related.
Yeah. So the first thing I'll say is we didn't leave Dropbox to start Convex, right? We left Dropbox. So I've been there a long time and
Yeah, of course.
done enough stuff. And Jamie and I wanted to just build some applications. And we had some really cool ideas for startups, right? And
Hmm.
so we started, building applications. And we're like, wow, this sucks. Like I can't like, but also a lot of folks might not realize this. Like if you work at Meta or Google or places like Figma or Quora, they all have their versions of Convex. So they have something that looks a little bit like Convex, right? And I'll
Yeah.
talk about what Convex is in a second. So you might take it for granted how bad the development state of development is for folks graduating from web apps into applications that scale and can and take on multiple engines. So you came out and it was like, wow, okay, the status quo is either go deploy your own kind of Kubernetes and this and that, like or use AWS as primitives, which are great primitives, but they are not like a sound abstraction designed for application developers. And then the state of databases was really depressing for me, right? Because in a few ways, one, um, most I'm just gonna why don't I go in on a spicy take, right?
Yeah.
Anyone who deeply works very deeply on infrastructure does not love MySQL or Postgres, right? You say, wow, these things kind of suck, but you know what? That's the best we have. Great. They've been hardened in a lot of ways. I personally think that MySQL is more hardened at scale than
Hmm.
Postgres. Postgres has, I'll say MySQL's bottom half of the stack is better. Postgres's top half of the stack is better.
I think you had a conversation with Jamie a few weeks ago, and you were talking about those two, like the storage part of MySQL is better, and the interface of it, the top and bottom. You were talking about that with Jamie in a chat a few weeks ago,
Yeah,
and I remember that.
so start to look around. So if you're in a large company, your developers aren't all writing handcrafted SQL queries, right? And because that breaks. So SQL, by the way, is a bad abstraction, right? SQL is because it's so easy to express in SQL queries that look very efficient, but when you run them, are extraordinarily complex.
Mhm.
Like very easy to materialize to write a join that materializes an entire table or select random and various things. So SQL, sure, it's given us a lot over the years, but it's not a very sound abstraction. You have to know how databases work to effectively use SQL at scale. And so large companies don't do this. Large companies have some abstraction layer that hides all this stuff. You have, like a really, really powerful ORM in many respects. And almost all large companies, the way they're structured is client, RPC services that run on a server that have authentication in front of them, that run in a secure environment, that are code reviewed, that issue transactions
Mhm.
against the database, and they're close to the database, so that latency round trip is very short, and then send the result back to the client, right? And that's to me, and the Convex, by the way, looks just like this, right? Um, Came out and started looking at how people are developing applications right now. And in many respects, they'd given up on this model, and you have client applications writing SQL queries directly against the server, directly against the database, right? SQL on the client, directly against the database. And you're like, wow, that's not very secure. Like, because you could run any old query. And I'm going to throw GraphQL in this category too a little bit. That's not so secure because you're exposing your database to the client. Well, let's add row level security rules. But then you end up with quite complex row level security rules to try to lock this stuff down. And we'd gone as an industry, I'm going to say the web application development industry, down a strange path from my perspective, a strange path that is very convenient to get started using, but does not at
Mhm.
all resemble how any large application is built, right?
Yeah.
Because it's very difficult to manage these things at scale because of the complexity that arises, and in particular, the lack of transactions. And maybe I'll pause for a second, let you jump in, but
Yeah,
I'll talk about
I'm
transactions in a
wondering
second.
what leads because I see this pattern I've seen this pattern a number of times, right? It almost is playing out in like, in some ways on the JavaScript ecosystem as well. And it's like this idea that like the thing that is the most convenient for the client, right, is the thing that often gets the largest developer mind share.
Yes.
And then it just becomes this new standard. And then no one thinks about how the system is supposed to run. And then you build a bunch of patches on top of it that seem to solve these problems. And then no one stops and says, why are we working on this problem? Because there is a better system that can be designed. And it seems like Convex is like is that like stop, let's just figure out a better system to design and we don't have to worry about any of these problems at all.
Yeah, I wonder, can I share my screen
Yes,
and
please do. Please do. Let's
give
get
you a look.
get right into
I
it.
want to
Yeah.
give you a little demo because I haven't explained what Convex is. That might be confusing to folks. And so Convex is a backend as a service. So yes, I guess it's a database. It has a database in it, but
Hmm.
the interface to Convex is your backend. Convex is your compute, is your scheduling, is your storage, and in particular, Convex is your state management. And that's a very, very critical thing. Convex is your state management. So what does state management mean? So here's an application I have here. These are two this is just a really silly little app I built on Convex years ago to demonstrate the platform. So and this is two different browser sessions I have here. They're logged into my personal and my work account. So this is a silly little application here that's like a shopping cart app, right? So,
Yeah.
and you can see when I'm adding stuff to the cart, what's happening here? Well, I add the hovercraft to my cart, it disappears from the other browser session. This is live on the internet right now. This is not running locally, right? So it instantaneously disappears from everyone else's items because they can't buy it. The totals increase in my cart, the available stock goes down, etc. Right? And this is a pretty simple app, but this is a difficult app to develop without transactions and without state management because there's a lot of things going on here, right? When
Mhm.
this hovercraft goes away, everyone needs to update their local state
Yeah.
to make sure that there's no longer a hovercraft and you can't be displaying it anymore. What would happen if the hovercraft was still there? Well, someone could try to buy the hovercraft, even though it was no longer in stock, and you'd have to have logic to figure out what to do in that case, right?
Yeah.
And by the way, there's two separate React components here, right? There's a cart component here, and there's a items available for purchase React component here. There's two separate React components. Actually, there's nested components as well. So when
Yeah.
I'm adding something to the cart and removing it, both these components are updating at the same time, right? Now, ordinarily in an application, there'd be a lot of really complex logic to add it to one component, remove from the other component, and make sure that you don't ever see a situation where the item is in both components, right? And yes, it might seem easy. I promise you that the complex part of any large application is state management. That's unless you have some offline app like a video game that has not multiplayer or whatever. But as soon as you have anything multiplayer, as soon as you
Yeah.
have anything persistent, as soon as you want to be able to lose your laptop and have your state stay around, you got to deal with state management. And sometimes people think the hard part of infrastructure is deploying servers, or the hard part is like connecting to a database. Like, connecting to a database is very, very easy. You can figure that out in 5 minutes, right? The hard part is managing distributed state.
Hmm.
So so you see this app, great, right? So I want to show you what this code looks like in Convex. So in Convex, oh, by the way, this is also the Convex dashboard. Everything in Convex is reactive. So I can go and let's go back to here and take the hovercraft. So other James can't buy the hovercraft. I'm just going to go and add a couple more hovercrafts in stock, and now it's there for
Now
purchase,
it's
right?
there.
So
Yeah.
everything in Convex is reactive. I can go and see the application health. Right? So this is a live production application. So let's have a look at the query that lists the items in stock here. So I'm not sure if you can see this here.
Yeah.
This query just says um, look up the number of items and return them. Right?
Yeah.
That's a particularly interesting query. Now I'll show you one of the mutations. Um, this is the mutation to add an item to my cart. Right, so I'm over here clicking add to my cart. Now, this is quite hard to do without transaction. Now, what is a transaction? A transaction
Yes.
makes services behave the way you think they should behave, right? So this is the logic for adding something to my cart. Right, first check that the user is authenticated to do whatever the hell they want to do, right? By the way, in
Hmm.
Convex, what one thing that's interesting about Convex is it's the backend platform that is includes a transactional database. And in that transactional database, the queries are TypeScript functions, just regular TypeScript functions that execute transactionally. So this is the mutation here. Um, First, we check that the user is able to do stuff. Then we log that they're adding something to the cart, right? Then we check if the item exists and has sufficient stock. If not, we throw an error, right?
Hmm.
Then we add the item to the cart. Then we decrypt. What are we doing here? Add them under the cart. Then we deduct the stock from the items, right? And then we commit. Now, if something failed in the middle of this, nothing would happen. There's
Nothing
no
would.
scenario here where you get halfway through and the items in the cart and it's also in items in stock, right? It just does all these things simultaneously. And by the way, there are if statements in this. I don't know if people think about this very often. There are no if statements in SQL.
Yeah.
There's selects, right? You could sometimes make this work with joins and selects, right? But typically, when you're writing SQL code, if you're a larger company writing SQL, you're doing so from an RPC running on a server, and that server's using some kind of ORM, and it's calling begin transaction, issuing a bunch of statements, and then calling commit or
Yeah.
or abort. And so this is something you can't necessarily do in the client setting. You can't run transactions from the client to the server because you can't trust the client. The client might start a transaction, take a bunch of database resources, and go away. So this is the transaction to perform this
Yeah.
card addition. Um, the key of this is you don't have to think about what you're doing. You just write it like you'd write a regular function. And you can have two people adding things at the exact same time, and everything just works. There's one more thing I should add, right? Which is how is the client app staying up to date, right? So I've just talked about how you write a transactional function to perform database operations. And by the way, we have folks using Convex who have 1,000-line transactions that are calling all sorts of separate functions and helpers. By the way, typically to compute access control checks, in a real application, it's quite hard to do so with row level security rules. Typically, you have a
Yeah.
big function that says, can this person do what they want to do? And
Right.
it checks
Yeah, you have a whole module
plan
for
they're
those
on.
things. Yeah.
Are they flagged for abuse? Well, this is how like real applications work, right? Um, so interestingly, how does the app stay in sync? So now I'll show you. This is the client code. This is just this is React code. This is literally the app
Yeah.
running. This is the items component here.
Right.
It says items equals use query. It called that list query we saw before, that list
Hmm.
query that fetches the items from the stock. And then it just maps them to a div and returns them, right?
Yeah. It's
And
so
that's
beautiful.
that's kind of the magic of convex. It's hard to know like what to point out as the magic of convex, but I think it's a few things. It's TypeScript transactions running on a server, right? And by the way, the fact that it's TypeScript is nice because your application's probably TypeScript is all the same types. You have full end-to-end type safety. And you have dynamic subscriptions. Everything in convex is reactive. So you can take any query on the server and bind it to a React component, and it will just stay up to date. You don't have to, you can turn off the reactivity if you want, right? Um,
Oh, you
Moreover,
can. I didn't know you could.
is you can just fetch things and not actually have sometimes people don't want their apps to live update, right? All you
Mm,
do is fetch the state locally on your app, and then you can decide whether to re-render it or not.
got it.
Um, but interestingly here, just to point out here, there's two separate React components here, right? There's one on the left, one on the right. And what's happening is when you saw that mutation to add something to my cart, all it did was say kind of add it to the cart table and remove and decrement the amount in stock, right? It didn't say anything about these React components. So when you're writing these queries, you don't have to think about what React components you have, right? And this is the thing about simplicity and scale, right? You don't want to be in a situation that when you're writing transactions on the server, you're thinking, huh, what are all the scenarios out there where someone might have read this data,
Right.
done something on
Right. You have to think about all your clients and
it?
you're like, yeah.
That's when applications grind to a halt. That's when companies fall apart, right? And I can, I manage a lot of large software teams, and I can tell you that if you want your system to scale with the number of engineers and the number of features you want to add, you want to decouple your logic, right? So all the add to cart transaction does is add it to the cart. Okay?
Hmm.
And then we have two separate queries here. One on the left says, give me all the items in stock. One on the right says, give me all the items in my particular cart. And convex guarantees that they're always consistent with each other. So this you might
Yeah.
not even know this is happening, right? But we have this WebSocket protocol that if a mutation comes through and it goes and adds something to a cart, it guarantees the client always sees a consistent snapshot of state on the server. So there's real end-to-end consistency. I mean, the client always sees exactly a consistent, internally consistent snapshot of server state. So you never have to have logic on your client that says, well, what to do if the hovercraft's in both places? It
Yeah.
will always be where it needs to be.
Yeah. It's such an interesting way to hear you describe this like this because, I always used to think of like Convex as this like database that gives you real time for free. And it's sort of like, yeah, that is true. And it's sort of like, but it's not a kind of bolt-on feature used to make it more interesting.
Yeah.
It's actually like would you say it's kind of like a core design decision that you made that based on the fact that like yeah 99% or all problems in large scale distributed systems are related to state management and essentially making sure that uh, you have this like it's sort of like this push based mechanism where you're pushing all updates to everyone just by default so no one has to think about it.
Yeah, yeah. I mean, so Convex wasn't designed to be a live blocks competitor. I mean,
Yeah,
you could use Convex for live block style workloads.
right.
And it works just fine for that, right? But the genesis of Convex wasn't that. The genesis of Convex was like, wow, I think people might be designing things wrong.
Yeah.
The genesis of Convex was like, huh, I've seen how large companies do stuff. And I've seen where the complexity emerges, and I want this for myself as well, right?
Hmm.
And so why is React popular, right? Because by the way, we've just taken for granted React and a lot of other frameworks that are similar to React that have like this kind of reactive paradigm, right?
Yeah.
we take it that React is revolutionary. That's a really different way of doing things, right? So like React like binds UI to data changes. And when the data changes, it re-renders the UI components. It's very functional. It's like almost like a functional programming concept, right? And
Yeah.
React got popular for good reason. React and similar frameworks got popular on in application development because it takes away the complex the problem with data management. Like React, Convex is like React but full stack. Like yeah,
Yeah.
so
Yeah.
you've got like okay, cool. React is nice because yeah, you when you're building a React app, most of the time you're just fetching data, updating data, whatever, and your everything just re-renders when it needs to re-render, right? All well and good for a demo, right? But then what happens when you actually have to store that state somewhere? It falls apart, right? Like all of a sudden, that abstraction breaks because you have this consistent, automatically re-rendered UI
Yeah.
that is not consistent with state in the back end. That's where you have all this conditional logic. And by the way, huge fans of Tan Stack. Tan is also thinking about these kinds of things. Um,
Yeah.
and so Convex, in some respects, is React for for full stack. It's full stack React, right? It's reactivity all the way from the client to the server. So the genesis of Convex really was like, wow. Like, firstly, I can't believe people are still building apps this way. At the time, it was like, wow, I can't believe web devs are so passionate about Postgres. I was like, what? Like, I have a PhD in databases. Like, I'm a passionate about like it's just the ugly tool that we have to use. So
Yeah.
I'm like, wow, that's weird. That's weird, right? That's weird. Like, shouldn't they be more passionate about like application development and state management? Like, so like, because at large scale, like, folks aren't passionate about these things. They're passionate about the more important issues that arise around state management. So it was like, wow, transactions are dying. That's bad. Like, we need to get transactions back into the world, right? So like, RP, and so why were people moving away from transactions and why were people running most of their business logic on the client? Well, it was because it was really annoying to use,
Yeah.
right? Like you had to
Yeah.
go and have an API team. I mean, so yeah, it's not all perfect, right? So if you're at a company like Dropbox or any large company, right? There's the front end team does the front end,
Yeah.
and then there's like an API team or whatever team, and you're
Yeah.
like, hey, I need some way to access user state for blah blah blah, and then
Yeah.
you have to convince someone to write that for you and add it to like a to the your Flask service or whatever. Um, and um, and so the genesis of Convex was like, wait a second, I think all application developers can be full stack developers, right? They're capable of it, right? But they need the right primitives. So if we make it so in the same language you're writing your front end, you can write like back end code, frankly,
Mhm.
give people transactions, and then solve what I think is the hardest problem in distributed systems and maybe the hardest problem in application development in general, which is distributed state management, then anyone or anyone who's like a qualified talent engineer
Yeah.
can build amazing full stack
I
applications.
mean,
And
this
that's
is like, yeah, this is so interesting. I mean, I think just to sort of cap that off, like one of the most interesting things that you just mentioned there is the fact that like, you have these teams that have been set up around these like, you have your backend team, your API team, and then your client team. And the reasons that they're doing that is because everyone wants to provide those teams with autonomy, right? But the technologies that exist for us to be able to like have that autonomy come with the the kind of downside of that is that it requires, when it comes to the state management issues, which are some of the most important issues where clients and servers need to stay in sync, they are just it requires just a ton of coordination. And coordination is the thing that gums up any organization, right? So, or coordination challenges. And so like it's such an interesting way to approach this. And I love the kind of transaction approach. Um, I could talk about this for a long time, but I would love to just switch tracks really just to talk a little bit more about like your component ecosystem on top
yes,
of
yes,
Convex, because I
yep,
think that's also a very, very interesting kind of like uh kind of add-on benefit of being a part of the Convex ecosystem is that you get to benefit from these components that come with a not just these like client functionality, but actually entire like a like extensions of your backend. right? Which I think is actually very interesting. I'm curious like how you got to that, how that component architecture is set up and like and maybe some of the stories around that. Like
Yeah. So like I think there's good reasons um a developer might be skeptical of Convex, right? Because she'd be like, hey, this is a different way of doing things. This is a different way that makes me nervous because I don't want to be a innovator here. Like I want to use the boring standard thing. That's a very reasonable instinct.
yeah.
And you might be like, hey, if I'm in this ecosystem, how limiting is it? Like, am I stuck in this ecosystem? And then when I outgrow it, like
Hmm.
in a difficult situation. So the first thing I'll say about that is Convex is not a crazy way of doing things. Okay? Convex is ultimately transactions on a database running from an RPC server that's next to the database with state management, which is pretty cool new thing, right? But it's architecturally has much more in common with how most applications in the world are built, right?
Yeah.
Um, but the question about like lock-in and feature set is a really valid question, right?
Hmm.
Because you'd be like, okay, cool, I love comments. What happens if I have a use case that isn't met? So, I mean, Convex is programmable. And so my answer to this is Convex is, and sure, Convex is open source and you can go and fork it and do whatever you want. That's not a good answer, right? That's not a good answer for most people. I can't say with straight face, oh, just go fork Convex and run it yourself, right? You're a company, you're using Convex because you don't want to deal with infrastructure. You probably don't want to deal with by the way, there's a lot of people running open source Convex, but like I think that's more of an enthusiast kind of thing, right?
Yeah.
Folks want to know,
Yeah.
hey, can I just keep using this for my application?
Yeah.
And so it's very important that Convex provides really good, powerful, clean abstractions that compose well, and then programmability and extensibility so that it doesn't box you into a corner. Right. And
Hmm.
so, and by the way, yes, you can also stream data out of one thing that's missing in Convex, by the way, we don't have any support for native support for OLAP for analytics queries. By the way, you also should not be running analytics queries on Postgres. A lot of people are doing it. You should not do that. That will break as soon as you have more than a handful of users. So you should be using something like Snowflake or Databricks or BigQuery or whatever,
Yeah.
and so folks just stream data out of Convex into these services. So what's the point of the component system? I don't want Convex to be a massive, heavy thing with like a
Right.
huge number of APIs. Convex is meant to be clean. Convex is meant to feel like an operating system. It's meant to feel like the kernel of the operating system, not the UI and everything.
Yeah.
So Convex, what does Convex provide you? Well, it provides you the ability to run real code in a sandbox transactional environment, right? Okay, cool. So now you want to do something interesting. You want to have a workflow system, or you want to have some AI agent framework that handles everything and stores state and streams values to you. Or maybe you want a Stripe integration or this kind of stuff, right? And I don't want folks coming to us and saying, "Hey James, like I can't use Convex. You haven't added Stripe to your API, right? What I
Yeah.
want to do is like, hey, it's programmable. Like, so we have a feature called components, and a component is the ability to run your own code inside a sub transaction inside Convex. And it's something that components probably no one understands, but I think it's hella cool. And this was the
Mm.
hardest part of building components, right? Components aren't just libraries. So we have, for example, I'll give you an example. We have a component called the work pool component.
Yeah.
So oftentimes people schedule like Convex has scheduling. You can run a job in the future, right? And sometimes people have like 10,000 requests come in from a third party service. And they just dump all these jobs in the scheduler. And now they've got to process through 10,000 requests, or maybe it's a million requests, right? And that might slow down other async background jobs they do. So they might want to have different work pools that are running parallel, and they have you can size them up and size them down, and all this kind of stuff, right? So that's not something part of the Convex core platform. Workpool is a component.
Yeah.
So you instantiate the workpool component. It has an interface, right? Workpool has its own tables, right? Those tables run in like its own namespace in your Convex database. But interestingly, if you're running a Convex function and you call a mutation on Workpool or a Stripe integration or anything like that, right? That is running in its own transaction as a sub transaction, right? So
Yeah.
because this is quite important, and maybe if folks are not like serious distributed systems people, they might not think about this, right? I have a transaction running. I have the transaction to add something to my cart. And in the process of that, I want to go and use the resend component to queue up some email, and I want it to be a durable email, or whatever, right? Um, that top level transaction might fail. It might fail because you get towards the end and you say, "Oh, wait, I don't want to let the user do that anymore. I don't
Yeah.
know. They're not allowed for some reason,
Yeah.
right?" So you don't want to be in a situation where you've called into the resend component, it's sent the email, right? And then you cancel the top level transaction. Because all of a sudden now you've leaked state
Yeah.
an uncommitted transaction. That's a very important thing about transactions. They should never leak state from your system, right? So in Convex, everything runs as a sub transaction. So you don't have the component doesn't have to think about what's happening above it. Doesn't have to know who's calling it. It just it just executes like a transaction. But that transaction is underneath the top level transaction, and so they'll all commit or abort together. Now, there's a
That's
lot of yeah,
Yeah, that's so interesting. I think, when I look at the components, like I use the workflow component, and the workflow component essentially allows you this it allows you this the guarantee of execution. Like if something goes
yeah,
wrong, you can it can last for months on end, right? And I think I had this hunch that the transaction architecture was what led to you being able to do those types of things,
absolutely.
right? And this is where going back to kind of our like one of the most interesting parts of this is that like this transaction architecture, this sort of like reversal of the database architecture, has led you to be able to create products or like uh, these create abstractions and interfaces and ultimately end products that developers can use that were were really a result of this like maybe like a singular technical choice, right? And
Yes.
I think that's probably one of the most like fascinating parts of the Convex story to me is yes, you get the reactivity as part of that, right? But then you get this like component architecture and these components can have these types of these properties because it's all running in a transaction. That's a really interesting way to even like build a company, right?
Yes. But you know what? It's also not completely novel because
Yeah.
everyone has an intuitive understanding of this. Like anyone that's been in a large software team or even a team
Yeah.
of two people, right? When you're writing forget the back end, right? You're writing some software um, that's multi-threaded. Multiple things are happening at the same time. If you're in a function, you're trying to write a 200 line function, right? Let's say a 100 line function that accesses a bunch of variables. If at every line of code in your function, you have to reason about, "Oh, what happens if this variable changes by some
Yeah.
other function while I'm in the middle?"
Yeah.
You wrote a crappy program, right? You've written non-thread safe software, right? And there's lots of bad software out there, right? If you just imagine there's the simplest multi-threaded code. There's two functions running at the same time, right? And they do 30 lines of function. Each function is 30 lines long, and they access three variables, right? And if every time you're in a loop or in an if block and you read the variable value and then you make some decision, and between the if check and the decision getting made, that variable changes because the other function raced with you, right? That is the absolute distributed, like absolute, concurrent execution nightmare. That's what people call racy code, race
Yeah.
conditions, right?
Yeah.
We all know race conditions are bad, right? But for
Yeah.
some reason, when we move from like really simple, basic local apps to like very hard, big applications that have distributed state in a database and a million clients out there, all of a sudden we
Yeah.
say, well, I guess I'll just deal with some race conditions. Well, guess what? It's way harder that way because you
Yeah.
because you don't. There's more developers, there's more concurrency,
Yeah. Yeah.
um, and so the real core thesis of Convex is just thread safety. I don't know, transactions. It's
Yeah.
like basically like you can, early on, I would talk to folks about Convex, and they would have known me because I've worked with them before, or I managed them, whatever. And they're like, oh, well, I guess if you say it's good, it must be good. But I'm sure it's the right way of doing things. But we need to move fast right now, so we
Yeah.
can't use convex because
Yeah.
that must be slow. And I need to move fast, so I'm just going to do the simple thing, right? And the whole point, I'm like, no, no, no. You should not use convex because it's safe. You should not use convex because it's good, or it's like eating your vegetables because hey, like your data's consistent. You should use it because it's way, way, way faster to write code when you don't have to think about race conditions while it's executing.
Yeah. And I mean, it's the first time you make that decision to manage that one race condition or you work around it, you
It's
have
all over.
now essentially said your success is going to work against you,
Absolutely. Anyone who's
right?
reading
It's
back-end
like
code and
it's like
like
it's like
yeah,
you know that as soon as your product takes off, that is going to be 15% of some engineer's brain space, right? And then it's just going to compound on top of that. And this like I think it's like the simplicity of the mental model is probably the core of this that I think is the most interesting. So, I mean, I love how this conversation we sort of weaved in and around like the technical discussions and the technical decisions, but then it and how they make way to uh working as a team, working together as a team. So like as you use Convex internally and you've seen team scale, right? How what are some of the happy accidents that you're seeing along the way that as you're building Convex as an organization that you're like, that you're realizing are happening because of these types of decisions?
yeah. I mean, one is that there are a generation of developers who now think this is normal. And I'm like, wow, that's cool. Like, there's people who are like, oh, doesn't the front end always update when the back end changes? Or don't transactions always? Uh, and I'm like, oh, not really. I mean, go back 10 years, sure, but not really. So that's one really comforting thing. The other thing I'll say is like convex value prop. When we selling someone on convex, like, oh well, convex is transactional, or it's type end-to-end type safety, and it's TypeScript, or it's reactive, right? And so if you ask someone on day one, like why you use convex, they'll probably say one of these things, and then
Mhm.
maybe say it because they think it's cool, or they'll say it because someone told them that's what they should say, and blah blah, right? But then if you ask someone after 2 years, like, why using convex, they're like, I don't know, it just feels good. I like using it. It just makes me work faster. Um,
Yeah.
but I just thought of something. There was a very big happy accident, right? Because we designed Convex for human beings. We designed Convex for scale and abstraction, composability and to move fast. And then LLMs came along, right? And then we're like, huh, I got a theory. I got a theory that LLMs are way better at writing convex code than like using a traditional SQL backend. And a
Mhm.
lot of folks were like, no, that's not true because there's like so much SQL code out there on the internet and LLMs are trained in it. Well, guess what? Like writing SQL is easy, right? That's not the hard thing for LLM to do, right? What the hard thing to do is building a full stack application where all these things fit together, right?
Mhm.
And there's not LLMs, by the way, are not good at distributed systems. They
No.
just not like, and maybe one day they'll get good at it, but I think there's reasons why LLMs aren't good at distributed systems because it involves a lot of non-local reasoning, right? The whole point
Yeah.
of distributed systems is you're changing the user table over here and how the users get managed. But by the way, that relates to the email system over here in a completely different way that is not in your context window and would not be obvious unless there's transactions involved.
It's not in the training data set. I mean, they're trained on these libraries that are built for these like components in that live in isolation, but they cannot hold the idea of both managing both like the server and the client together well enough
And
yet.
you can't run
Yeah.
an eval easily on distributed systems because it's not obvious that they work or not. You can't easily run an eval on whether a system can be expanded over time and
Mhm.
maintain functionality without getting complex to manage, right? So LMs just, by the way, just yeah, like they're just bad at writing distributed systems right now, right? So there is a lot of merit in having abstractions that make distributed system problems go away. And it was really, really comforting when yeah, AI coding kind of started getting bigger, and we ran these benchmarks, these LLM, and they're just way better at convex. And you can just Google this stuff. We have like the
Yeah.
LLM benchmarks. Yeah, they're
I
just
mean,
way
I can
better at building.
I know from my personal experience that it's and I think you guys have done a great job with providing agents that context with the default agents.md and stuff that comes
Yeah,
with convex projects. So yeah, it's
yeah,
my
yeah.
experience.
They had to learn the syntax, right? And that was, but again, that's easy. Syntax is easy, right?
Yeah.
Emerging complexity is hard. And so, we put these blog posts out and we're like just, like trying to convince people, like, hey, look, it's like LM's way better at this. And no one cares about blog posts. And so we just built this thing called Chef. Chef is this
Yep.
AI coding app. So it's chef.convex.dev. Now, in some respects, I mean, Chef is still best in class at building full stack applications. I stand behind that. Chef is not the best at building aesthetically pleasing applications because think about how much effort's gone into stuff like Bolt and Lovable. We wrote Chef in 10 days, start to
I
finish.
heard.
Like
And you open sourced it recently.
it's open source. You can go steal the source code. It's Apache license steal. Don't steal any of our stuff. You can legally use our source code. Um, and so Chef, you just the way to benchmark Chef is go and ask it to do something hard. Like, I mean, if you go and say do a ball bouncing around in a polygon, like whatever, I don't know. I don't care. Like it's probably going to be as good as anything else, right? But if you say, hey, go build me a Slack clone that has multiple channels and multiple users, and the users can post at the same time, and you can have reactions and threads, whatever just head to head that against anything, right? Chef's going to do better. And it's not because we are like AI coding geniuses when we built Chef, because we wrote it pretty fast. It just works better because the primitives are better, right?
Mhm.
Because the primitives are designed to make the problems go away. LMs don't have to reason now about race conditions or what happens when. And by the way, these are just demo apps, right? The real power shows up later on when your app's bigger. But I think Chef. I mean, Chef's not a core like product of ours. Like Chef is, like I said, it's open source. You can take it. It's Chef is a demonstration of Convex.
Mhm.
But I think that was the happiest accident of the last year, which is we're like, wow, AI coding. We better have a. And by the way, I should give Theo credit for this because Theo
Yeah.
was the one who was like, hey, you all should build a coding app, and so we did. And that was very comforting that what is good for humans is good for LLMs. If that was not the case, it'd be sad because all of a sudden humans would get really bad at managing their own systems, and it makes me comforted to know that if you're optimizing for LLM performance, you're also using the platform that makes it good for humans to go understand and modify the code themselves.
Yeah. Wow. Well, listen, I think I could go on for a long time, but we're close to time. But so I'll end it here. But thank you so much for kind of walking through this, James. I think is there anything that you want to kind of leave people with? Kind of like, everyone knows convex.dev is where to try it out. But is there anything else that you want to leave people with?
Yeah, you go to Convex, try it out, do our tutorial. There's a few little concepts to, like you said, there's a few concepts to wrap your head around. If you're more used to, say, the super base way of doing things, it's different, right? So you just got to wrap your head around Convex, and then I think you'll find it very easy. But the lesson I want to leave with people is like, especially if you're a junior engineer, if you're kind of early on and you want to be like an excellent engineer, the way to do it is to come up with simple systems, right? That's simplicity is not the hallmark of a dummy, right? That the simplest things are the hardest to develop, and so I would just encourage everyone to keep it simple, and then we'll be in a world with systems that can be modified and extended and all that kind of stuff.
That's awesome. Thanks so much, James.
Thank you,
I'm
Tarun.
gonna I'm gonna